Hi, I'm at the University of New South Wales for other reasons, and I've got a tour of one of the electronics labs here. And I'm with Torsten Lehmann, who's Associate Professor here, and you're in charge of this lab. This is yours,
This
baby?
is used for my electronics course, so this is a very typical electronics lab at the university. So let's go in and have a look.
Let's go in. Okay. So this is not your only one?
We probably have these labs, probably about 4 or 5 in the school.
Oh, okay.
The equipment is somewhat different, but you know, you got your basic signal generator, power supply, oscilloscope, and an SMU on a computer.
Yep.
Then typically the students make circuits on a breadboard and test them out.
Well, as we'll see, you've got a mix of different types of test gear. Is that for different reasons? What about test gear selection? I know we're getting into this early.
Yes, okay. So test gear selection is, you know, we have to have the basic 4 different types of equipment. Yeah? Mm-hmm. So power supply, so we can power things, and oscilloscope, so we can measure things, and so forth. Now, in terms of, you know, exactly what gear we have, it's not very high-end. It's not necessary when you do a design on a, you know, on a breadboard. Yep. It's not really high frequency or accurate, anything like that. So what we get is to have something that's affordable and reliable. That is the main criteria for selecting the gear that we have there.
And a significantly different gear over here.
Yeah, so this was what we did for when we had COVID, so we couldn't have any students in the lab. So what we did instead was for pretty much, you know, all the courses that rely on electronics, you know, analog electronics, other courses, signal processing, where we do need to have some electronics sitting in there to measure on, then what we did, we constructed a custom PCB, one for each lab. Essentially, it has a bank of relays that is controlled by a National Instrument data acquisition box. It's hooked up to, you know, a crow here. It's a Roden-Schwarz crow. With the probes and also signal generators, a built-in signal generator in that. So with that, the students can log in and control the relay positions. The relay could switch in the signal generator to one part of the circuit or another part of the circuit. The crows are just hooked up to, you know, points on the PCB, but they can then maybe switch where it's being measured in the circuit, so it's completely remotely controlled for that. The students can also log into the Roden-Schwarz web interface and essentially use the crow remotely.
I was going to say, because the Roden-Schwarz has a very nice user.
That is exactly why we got the Roden-Schwarz one.
Right.
Because
so you got those during COVID, or?
We got those during COVID
right.
for the purpose that we could use them there. There's other crows we can use, but Roden-Schwarz, because it has a built-in web interface that has complete access to the whole front panel, that's certainly the best one.
Got it. And you've got a webcam, so they can technically see what they're working on, but really there's not much action going on.
There's not much action here. There's not much action here. Though we have some other setups where there's one over there where there's actually the just for make it a bit more fun, we have on this side over here. So here we actually have action because
right.
Because on this one here, there are motors that physically move a sliding potentiometer, and then you can watch and see what the positions are. So that makes it a little bit more sort of...
No, it makes it more intuitive and...
Hands-on. Sort of, it looks like you're actually doing something, and it's just a computer simulation. It's actually hardware doing stuff, even if you sit at home.
Got it.
Yeah. So.
Do you engineer in faults and failures and ground bounces and other things, or is this more basic?
So this particular one is more basic. So we have a course where ground bounce and power supply decoupling and interference between supplies is core, and that's, you know, the electronics course. And for that course, we have a PCB that is set up where there's not fault as such in it, but there's deliberate paths where you can increase or reduce the ground bounce, for instance, so you can measure that. Yeah. So, right. But that's a different board, but it's the same idea.
Got it. Because you're specifically running a course that is more practical than your more traditional EE theory course. Can you explain that?
Yeah, that is correct. So the electronics course was conceived here at the university probably about 15, 16 years ago, and that was a response to needs from industry and need from researchers and and myself, that it's not enough to just know how to build an op-amp on a pen and paper design, because if you do that, you can get whatever you like. Yeah, in reality, you're limited by the bandwidth, you're limited by the power supply interference, you're limited by the output voltage range you get, and all sort of things that is not in your sort of triangle drawing on a piece of paper. So this course is really about making sure that the students appreciate and understand and can use electronics and get it to work.
Exactly, because that is one of the complaints, is that, university graduates, they don't know how to solder, they've never used a breadboard, they don't know how to use an oscilloscope. That happens at some unis, but not here. You guys...
Well, that is the idea, that they should be able to do all of those things. That is correct.
Excellent. And you've got multiple labs similar for different purposes? And
we get multiple labs for different purposes. So some of the labs have, you can see here there's a solar panel and a light on top of the benches there. So this would be used for some photovoltaic experiments. There's other labs that has control experiments setting up where you have to, control an inverted pendulum, for instance, and other things like that. So there's to be honest with you, I don't even know how many labs we have. We got lots. Right. You probably have, I don't know, 15, 20 teaching labs, so this sort of thing. Wow. So some of them have different experiments and that. So for the electronics ones, that is just about the analog electronics, or the electronics course. There's 4 labs that is dedicated to that. Wow. Of this sort of size. So some of it, actually, this is a small lab. Some of the labs we have this side, well, the room is the same, but on this right-hand side here, there's also lab benches, whereas this is still in the COVID setup.
Oh, got it. Okay, but so post-COVID is now different. You're all back to normal.
Pretty much.
Pretty much. Students have to be on campus now?
Students have to be on campus.
Right, got it.
That's right. Because even though we have this set up, and I think we did really well during COVID to make sure that the students would still get hands-on experience, even though they couldn't be physically in the lab, it's still better being here physically, because there's stuff that you only learn if you actually assemble.
And is there always someone in here who can help them out, or?
So we are trialing some open labs so that we can keep the labs open for students whenever they need to come in.
That was going to be my question. Can they come in anytime they like?
Yeah. So we do have a number of design courses as well, where you have an open-ended design thing that you have to do. Is typically done on a breadboard, but it could also be having a PCB manufactured and soldered up, that sort of thing. And for that, the more lab time you have, the better. So we keep the labs open for those sort of design courses.
And this lab here, you've got Siglent scopes here, so the Siglent fanboys are going wild. Why was Siglent chosen? Was this before COVID? Because obviously you got the Roden-Schwarz specifically for its remote capabilities. Could these ones not do what you wanted, or?
I don't think these are particularly old. Honestly, I don't know why the Siglent chose. You should ask that question to Roy, because he's the lab manager. So
the lab manager would be in charge of, And is this setup over here different, or is this just the same? No, it looks very similar.
That is different. It's different setup, but it's the same.
So totally different. So the students can log into any of the different experiments that are set up.
Yeah. So we have to, we change the experiments as the term goes on, and then the student have to do measure on different boards, so it's all changed all over when
got it
during the term.
Right, and they can just phone up and ask somebody to come in here and change probes or do whatever?
Yes, that's correct. So they would log in on Teams or some online platform. You'd be using Teams, and there will be a lab demonstrator in the lab that can help them out. So we normally have lab demonstrators to help out the students for helping them with the problems they have. So, and we have had the lab demonstrators in here as well, and then the student would be able to raise their hand, and then their lab demonstrator could come over and put the probe up if it had popped off, or help them otherwise with the design. So.
And electronics is a compulsory part of the EE degree here, because I know at a lot of universities it's not sort of as such, especially the hands-on.
No, the hands-on electronics is compulsory at UNSW, an eighth of a year sort of thing. Yeah, so 150 hours is the standard time for a course, and so there's one of those that's compulsory, and there's with many others.
The hands-on soldering, you've obviously got another soldering lab where they can physically build projects.
So there is actually a soldering station down in the corner here, at the very end of the lab.
Well, let's go check that out.
And we have that in most of the labs. So for that, so it is.
There we go.
Yeah. So we just have basic
Wellers.
pen soldering.
Yep.
They're different brands.
There's different labs for.
But that's the basic setup that we have for soldering here.
Oh, there we go. We've got a mantis. Yep, very nice. Okay, JBC. There you go. Terrific. Okay, so now we've got more micro stuff, more surface mount work. Yeah, hot plate, all the rest of it. Nice.
So this is one of the things that we're working on to make sure we have more hands-on practice as well, to get, so at the moment it's not compulsory to do soldering, but we kind of want to work that in, and we're building up capability to do surface mount. We haven't had that previously, but if you buy a chip that is not 20 years old, it's going to be surface mount, and you probably need to have hot plate and hot air to solder something advanced on. So we're working on getting that going.
So as part of the EE degree, do you do a compulsory practical project of your own
you do,
choosing?
Yeah.
Or is it your own choosing, or are you given a set of different ones?
This is of your own choosing, something that you come to an agreement with an academic supervisor. So this would be a 1 year long course, so 3 terms we had. So probably so 3 times 150 hours is a nominal amount of work in that. And that can be in anything. So we have a very large variety of skills in the school. So that can be in electronics, or it could be in control, or in power systems, or in quantum engineering. So there's many different options for that. It could also be simulation based, or it could be hardware based. Many of we also have telecommunications. So many of those projects are, they use simulation as the main tool to get. If you do image processing, for instance, it's about it's a simulation project, not a hardware project.
Okay.
But there could also be hardware projects where you design a system around an FPGA, or you can do a microelectronics course, a project where it's probably also simulation based. But there's lots of different things. Yeah.
Wow. I can imagine there's a massive difference in potential complexity in projects depending on what you choose. How do you sort of evenly judge and grade? Somebody's working on some obscure leading edge thing, and others, I don't know, I want to build a little, a relatively simple thing compared to what somebody else is doing.
Well, the complexity can lie in many different places. So you build RF circuits, you build system which has 1 transistor and a couple of inductor, a few capacitors, resistors. That's it. And you can easily spend a year just perfecting the noise performance of that, even though it on paper looks like you only got like 10 components. How hard can that be? And
yeah, of course.
And then you look at the flip side, and if you want to build say a RISC processor, for instance, on an FPGA,
right?
You got millions and millions of components in there. So but it's not difficult to get one component to work. It's trivial.
Yes.
So the complexity can be extremely different, but that doesn't mean that amount of effort in order to get good results is necessarily different. So this has to be managed, obviously.
So somebody might have to do more work on the documentation side of it, the analysis simulation or something.
I wouldn't say that actually. I wouldn't say that because the documentation is fairly well controlled. So they all have to write thesis as you go. And,
of course.
So the amount of writing in that is the same. It's just the nature of the work can be quite different. Yeah?
Okay.
I like to compare that to playing an instrument. Yeah.
Right.
So you can play a say a trombone. Yeah? And to get the notes is a difficult bit because there's nothing to help you there. You just got to play it by mouth and ear. So getting a note is hard. You know, you compare that with playing a piano, getting a note is trivial.
You
press a button.
Yeah? It's done.
But that doesn't mean that it is easy to play a piano compared with a trombone. It's just that the difficulty lies in different areas.
Good analogy. Yep. Yeah. I like it. Basically, you've got different setups for different applications. They all seem, someone's building a breadboard at the moment, and they're all hovering around. Are they doing a class at the moment, or are they just in here on their free time?
I don't know.
Right, because you're not in charge of the lab at the moment.
I'm not in charge of the lab at the moment.
Right.
No, I would imagine that they might be doing it in the free time. They might have a project that they're working on, but I don't know.
Yeah, right. So you've got a whole bunch, like a dozen labs that are even bigger than this.
Yeah.
Right.
Yeah.
Excellent.
Yeah, well, more benches, but probably the same physical size, but more benches. Yeah. Up to 400 kilovolt equipment sitting in there so this is for research.
100 kilovolts, 250 kilovolts, yep.
Yeah, it should be a
400 kilovolt, 10 kilojoules impulse generator. Oh, I could blow some multimeters up here.
Yeah, you certainly can.
Oh.
You certainly can.
Wow. Okay, I know who to talk to if I need to blow up some meters. Fantastic, the high voltage lab.
Yeah.
But you've got to be certified to go in there.
Yeah. There's lots
Right.
of training. Otherwise you're not allowed to set foot in there.
Got it.
I'm only rated up to 30 volts. So
30 volts. That's good enough. Good enough for electronics.
Yep. That is correct.
All right.
So
more labs. Oh.
So these are also the power systems labs in there. Yeah, I think it's all 240 volts experiments sitting in there.
It looks like it. Yeah.
So,
very nice.
So lots of experiments on that.
Oh yeah, there we go. And wow, lots of custom setups. That's really nice.
Yeah, it's very common that we have a particular experiment that we want to do, and then we develop the electronics in-house, and also we have a workshop downstairs that can then help us doing the mechanical structures for that.
Got it.
So that's we have a lot of custom made setups. As such, as these levels here are except for the bottom end here, these are
custom
gear.
Gear.
The teaching labs.
Okay.
So on the high levels we have networking, we have photonics. Again, this is
Power electronics and drives laboratory. Yeah. Wow, very nice. Okay.
We also do battery testing.
Yep.
So also lithium batteries safety is very much.
Yokogawa oscilloscope. Ooh, the data logger of choice.
As we walk past here, there's I can log into the lab. Again, this is what we have on the right. This is an electronics lab, the basic electronics, but this is set up to doing control experiments. So there's a couple of physical arms that you can move around. I'm guessing, I don't know the experiment, but I'm guessing what you have on the left there is that you've got to use vision to move the devices around, and then you've got to work out the algorithms that will be the labs in order to do that. So, but you can see again, the basic setup is basically power supply and oscilloscopes, and
Okay, so they're following a lab exercise up there on the screen, and they're right. Yeah.
Okay. So this is a Makerspace that we have in here.
Hey, Makerspace! Woohoo!
And,
Awesome.
So this is the electronics Makerspace. We have At the moment, there's a lot of 3D printers in there, as you can see in the window.
Sure.
Hello. Hi, Gabba.
G'day.
Hi.
Nice setup, guys. I like it. That's excellent for all you tool aficionados. There you go. That's beautifully labelled.
And
this is a great makerspace. I like this. So this is like free use. Anytime you can come in.
it is.
Yeah.
It is.
Oh, terrific. Wow. Oh, there's your PCB, LPKF. Yep.
So they do PCB milling. Yep. So it's a milling machine.
Milling, yes.
Yeah, so I can do double-sided, but I can't do plated through, which we kind of want to move into an older solder mask, so it's a bit easier to solder. But yeah, you've got the surface mount soldering sitting in there, and
Terrific.
so the Makerspace run also soldering workshops as part of the induction to use the area.
Terrific.
So there's a number of different makerspaces at university. So this is the electronics one. There's also mechanical makerspace and some other makerspaces.
Nice. SLA 3D printers and all sorts of stuff. This is a great setup. I'm very impressed. I would have killed for something like this when I was at university. Like, we had nothing like this. Yeah, we had nothing like this. Unbelievable. Yep. You have to have your own workshop at home. You know, that's the only way you got stuff done.
Yeah, that's right.
Yeah.
Well, it's not very equitable because some people have that,
Yeah.
but not all. So it's good to have spaces like this where you can work.
Great stuff.